How's it going, guys? Today we're going to be doing another live, basically no editing. I'm going to talk through how I like to study the maneuvers in the Airman Certification Standard. So this is all going to be stuff on your check ride. Two things we're going to need are the Airplane Flying Handbook, and that is free at the FAA website, and the Airman Certification Standard for the private pilot, again, free on the FAA website. I'll post links in the description, as well as links for hard copies if you like having the actual physical book. In addition, I have my own PDF worksheets for how to study the maneuvers, and they're over here, and I'll post a link to them as well. Starting here, we have the maneuver, the name of the maneuver, the objective, the sketch. I want you to draw it out, the ACS parameters, common errors, and then notes for yourself as you study. You can say, hey, I like to do this or whatever to fly this maneuver. So first, let's go find a maneuver to study. Pull up the Airman Certification Standard. Airman Certification Standard. Go to the table of contents. We'll get there eventually. And here is everything you can expect to see on a check ride. All the maneuvers, all the topics you're expected to cover. Let's do something fun like steep turns, page 35. So I'm going to click on steep turns. Here it is. Here are your references for steep turns, FAA-H-8083-2 and 8083-3, and the POH, or the aircraft flying manual. And then the airplane flying handbook. We're going to go and find steep turns in the airplane flying handbook. This is how the FAA wants you to fly it, official sources and whatnot. Going to the table of contents, probably going to be performance maneuvers. Here we go. Steep turns. It's going to be page 10-1. Cool. Bam. So we have the airplane flying handbook, how to do the steep turns, and we have our parameters here. So let's start with the name of the maneuver. Come up here, draw. I'm going to say steep turns. Too easy, right? Look at that handwriting. Now, looking at the airplane flying handbook, it says the objective of the steep turn is to develop a pilot's skill in flight control smoothness and coordination, an awareness of the airplane's orientation to outside references, division of attention between flight control applications, and the constant need to scan for hazards and other aircraft and other traffic in the area. Figure 10-1. So this is what I want you to draw. I know it's silly, but actually coming back over here, the objective, we're going to jot down, develop skills. Not going to have enough room in here because this is difficult to write on. Skills in flight control smoothness and coordination, awareness of orientation with my atrocious handwriting. Outside references, division of attention. Oh my gosh. Between flight control applications and constant need to scan for hazards and other traffic. So scanning, we'll just add scanning. And you can actually write all of this out here. This is just tough to write because this thing isn't super helpful. Whatever. Next, I'll draw a sketch of the maneuver. So look at this adorable handwriting. There's this amazing sketch here. There's my airplane. That's the flight path. The first turn here and the second turn here. Oh my God. Beautiful. And we draw a little airplane coming back around, and then bam, turning inbound, and the second turn to the right, coming around, and returning back to our initial heading. God, look at that. Those drawing skills are incredible. All right. You get the idea, right? So first you start straight and level, you make a turn to the left, steep turn, you come back to your initial heading, and then you set up for your next turn and turn to the right, do the second turn, and then you continue on your merry way. Beautiful sketch, right? Okay, so continuing reading on. While the fundamental concepts of all the turns are the same, when steep turns are first demonstrated and performed, the pilot will be exposed to higher G forces. That's right. While we're doing steep turns, we're going to feel a little bit of G. The airplane's inherent overbanking tendency. Significant loss of the vertical component of lift when the wings are steeply banked. That's right. So as you're flying, you convert, when you're flying, you've got all your lift vertical. When you roll into a bank, you lose a portion of that vertical lift to horizontal lift, and that's what turns the aircraft, right? So in a steep bank, you're converting a very large amount of that vertical lift to horizontal lift. So you're going to lose altitude if you don't compensate with a little bit of nose up or power. The outside wing's going to be traveling faster, so you're going to have an overbanking tendency. So anticipate that. Okay. Substantial pitch control pressures, the need for increased additional power to maintain altitude at a constant airspeed during the turn. As discussed in previous chapters, when banking an airplane for a level turn, the total lift divides into vertical and horizontal components of lift, like we just talked about. In order to maintain altitude at a constant airspeed, the pilot increases the angle of attack to ensure that the vertical component of lift is sufficient to maintain altitude. The pilot adds power as needed to maintain airspeed. For a steep turn, as in any level turn, the horizontal component of lift provides the necessary force to turn the airplane. Regardless of the airspeed or I lost my place or airplane, for a given bank angle in a level altitude turn, the same load factor will always be produced. The load factor is the vector addition of gravity and centrifugal force. When the bank becomes steep as an level altitude 45-degree bank turn, the resulting load factor is 1.41. That means you're going to be feeling 1.4 Gs. In a level altitude 60-degree bank turn, the resulting load factor is 2. So at 60 degrees of bank, you're going to be pulling 2 Gs like Maverick in Top Gun. To put this into perspective, with a load factor of 2, the effective weight of the aircraft and its occupants doubles. Pilots may have difficulty with orientation and movement when first experiencing these forces. Pilots should also understand that load factors increase dramatically during a level turn beyond 60 degrees of bank. Note that the design of a standard category general aviation airplane accommodates a load factor up to 3.8 Gs. A level turn using 75 degrees of bank exceeds that limit. And that's why we pretty much always stick to between 45 and 60 degrees of bank for the maneuver. Because of higher load factors, steep turns should be performed at an airspeed that does not exceed the airplane's design maneuvering speed, or VA, or operating maneuvering speed, VO. Maximum turning performance for a given speed is accomplished when an airplane has a high angle of bank. Each airplane's level turning performance is limited by structural and aerodynamic designs, as well as available power. The airplane's limiting load factor determines the maximum bank angle that can be maintained in level flight without exceeding the airplane's structural limitations or stalling. As the load factor increases, so does the stalling speed. Keep that in mind. For example, if an airplane stalls in level flight at 50 knots, it will stall at 60 knots in a 45-degree steep turn while maintaining altitude. It will stall at 70 knots if the bank is increased to 60 degrees of bank. Stalling speed increases at the square root of the load factor. As the bank angle increases in flight, the margin between stalling speed and maneuvering speed decreases. At speeds at or below VA, the airplane will stall before exceeding the design load limit. So you will stall before you break the plane if you're staying at or below VA. So keep that in mind. Okay, moving on. You can continue reading this in the Airplane Flying Handbook. Moving on to ACS parameters. It's still in the same thing. ACS parameters. Here we go. Looking at the Airman Certification Standard, here's the knowledge that you're expected to know. And we can continue reading that if you guys want. I don't know how much you guys want me to just read it to you. You can go read this for free on your own. You also have to demonstrate the ability to identify, assess, and mitigate risks encompassing failure to divide attention between the airplane control and orientation, collision hazards, low altitude maneuvering, CFIT, stall, spin, etc. Distractions, improper task management, loss of SA or disorientation, and failure to maintain coordinated flight. Use your rudder. The applicant demonstrates the ability to clear the area. So that's the first thing you want to note here. Notes. Where's my pen? There it is. Clear the area first. Right? Look at that beautiful handwriting. Oh my gosh. Establish. Lost my spot here. Establish the manufacturer's recommended airspeed, or if one is not available, an airspeed not to exceed VA. Roll into a coordinated 360-degree steep turn with approximately 45 degrees of bank. And that's going to be here, right? So clear the area, VA, at or below VA, 360-degree turn, 45 degrees of bank. Perform the task in the opposite direction as specified by the evaluator, and maintain entry altitude plus or minus 100 feet, plus or minus 10 knots, and bank angle of plus or minus 5 degrees. Oh, and roll out on entry heading plus or minus 10 degrees. Roll out. So here are all your parameters. If you can nail all of these, you're in great shape. Common errors. Let's go back to the Airplane Flying Handbook for these. Common errors when performing steep turns are not clearing the area. So I can't stress that enough. Clear the area first. Inadequate pitch control on entry or rollout, gaining or losing altitude, failure to maintain constant bank angle, poor flight coordination, flight control coordination, ineffective use of trim, ineffective use of power, inadequate airspeed control, becoming disoriented, performing by reference to the flight instruments rather than visual references, failure to scan for other traffic during the maneuver, attempting to start recovery prematurely, and failure to stop the turn on the designated heading. All right, kind of rush through it. It's really not that much. It's like what, a page and a half, 1.5 pages of information. It should not take you very long to read through this on your own. If you want, I can do this for all these maneuvers. I don't know. What do you guys think? Let me know. And then, yeah, so write your common errors here and notes. When you go out and practice the maneuvers, you're going to notice, all right, I really like doing left side, but I suck at doing right hand steep turns. So make sure that, I use the appropriate amount of trim. I like to do 3 or 4 rolls of the trim wheel during steep turns, and I would put that here. Trim. I'm going to stop writing. This is worthless. Yeah, so that is steep turns. If you need help with the flight planner, watch this video here. See you guys next time.